Okay. Hi everyone, welcome back to the channel. So today we'll be discussing another problem from Get SDE Ready Question Bank. So let's open the problem. So the question name is black shapes. For all those who have not read the question, I would want you guys to please pause the video and read the question. So I hope all of you must have understood. For those who have not understood, I'll explain you guys. Okay. So see, basically you are given two characters, black and white. Now we have to return the number of black shapes, and a black shape consists of one or more adjacent x's. Okay, so for example, one or more adjacent, so its adjacent is this one, this one, this one, and this one. Diagonals are not adjacent. Okay, so this is mentioned in the question. Okay, now for example, let's see in this example only. Okay, see, this forms a black shape. Why? Because all of them are adjacent. This is adjacent to this one, and this is adjacent to this, right? Okay, same ways this forms a black shape. Why? Because this is alone and it is not basically adjacent to anything, so this is also forming a black shape. Similarly, this is forming a black shape. Okay, so basically there are three black shapes. Okay, so I hope all of you must have understood. Let's see, there's one more example given. Okay, so as you can see, this whole complete one black shape because all are connected to each other. Okay, you can't say that this is alone a black shape. No, because this is connected to this also. So this will form, these two will form a shape. But now you can see this x is connected to this, so basically these three. So all in all adjacent x's will combinedly form a one black shape. Okay, so let's see how will you approach this. Let's take this example only. What we'll do is we'll basically start traversing on the array, and wherever you find x, wherever you encounter x, what you'll do is you'll basically find or do BFS traversal on that x and mark all the adjacent x's. Okay, so suppose you are iterating this way and then going down. Okay, so first you'll encounter this. Okay, so now I hope all you guys know how to traverse on BFS, how to do BFS on a graph. Or okay, so what you'll encounter first x. Now what you'll do is you'll basically search for all the adjacent x's. Okay, so who all are its adjacent? This is adjacent, this is adjacent, this is adjacent. Okay, so you'll mark this by any alphabet which you want. Like suppose mark this as 2. Basically this is a part of an island, or a black shape which has been traversed, and it's all the adjacents are also been covered, right? So you need not to cover this again if it comes. Okay, so now when you'll see, okay, you'll see this is 0, this is not a black shape, so you'll basically remove and continue. Now you will encounter this, leave it because it is again 0. Now check this. Oh, it is a black shape. So first of all, convert this into 2 or any other alphabet which you want to mark as visit, and you will search for its adjacent. Now who all are the adjacent of this x? This one, this one, this one, and this one. So you will first let's suppose you check this one first. This is 0, so you will reject. Now you are checking above x. So what you'll see that this is already marked 2, which means it is already visited, right? This is already visited, so need not to check again, need not to traverse again. We'll simply return, and then it will check this. Now it will mark all the adjacent. Basically it will mark it as 2 first, and then it will mark all its adjacent, and then it will see this which is 0 and return, it is returned. So basically all in all you can see that all these 3 x's are marked by 2, so you get one black shape, you get one shape, right? Now let's clear this up a little. So now all these 3 x's are converted into 2. Now you will move ahead. This is 0, 0, 0. Here you come 0, 0, 2. Oh, already visited. Need not to go. It's 2. Need not to go. 0, x. Okay. So this is x. Now what you'll do is you'll find all the adjacent x. You will first convert it into 2 and then you will pass on the same problem to its adjacent. This is 0. This is 0. This is 0. Oh, this is x. So it will be converted to 2 and then again all its adjacents will be called 0. Oh, sorry, this is not adjacent. This one. Oh, it is 2. So it means it has already been visited. So you need not to check all its adjacent again. And this one, okay, this is 0. So need not to find its adjacent. Okay, so let's clear this up. So now you will come here 0. Now you will come here 0. Oh, x. You will convert this to 2 and call it all its adjacent. This is adjacent 0. No, no, no. So okay, so this will be converted to 2. Let's move ahead. 0, 0, 0. Oh, it is already 2. It has been visited already. So need not to do. It is a part of some island. So all in all, you have called, basically you have called recursion, or to mark 3 times. If you remember, first you called here, then you called here, then you called here. So basically 3 islands you got, right? Similarly, you can do for this also. Let's see, x, 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 x. You will basically call recursion, to mark all its adjacent. You'll see that all these adjacents will be marked. All these would be marked as. So this forms one complete group. That's why answer is 1. So this is just a single black shape. So I hope all of you must have got the approach. If you have any doubts, you can ask me in the comment section below. So let's see how will we code this. So this is the initial function which we are given. We initialize our answer to 0. As you know, we started traversing on the array. So this is the traversal loop for 2D array. This is the outer loop and this is the inner loop. Now if you know, we were always checking for x. Whenever we encounter x, basically we have got one answer. Like now this will form a black shape, and then we call our helper function, which will mark all the adjacent x's which are basically in touch with this. So now let's see what helper function does. In helper function, we are passing the array which we have got. We are passing the current row and we are passing the current column. Okay, so here we are getting vector, we are getting the current row and we are getting the current column. Okay, so what we are checking, if the row is less than 0 or row is greater than v dot size. So basically size, v dot size, which is number of rows, which is 3, right? 1, 2, 3. So if row is greater than or equal to v dot size, basically if we do its indexing, 0, 1, 2, so but the size is 3, so that's why if it is greater, which is not possible, right? Like these two indexes are not possible. Same goes for column. So we'll simply return. And again, if you know that if it is a white shape, basically somewhere it is white, so we can't find its adjacent because it is not included in the shape. So again, we simply return. Now what we do is we marked basically that current row or column, that current index as 0, which is, again, you can mark it as 0 because you're not iterating or you're not finding the adjacents of 0. So that's why it will always return from here only if it is called again, like x, o, x. So sorry, this one. Oh, okay, so suppose you start from here. So what you will do is you will turn this as 0 and you will turn this also as 0. So now when you will come here, you will simply return from here, or you will simply see that, okay, because we are only finding for x, so when you will, so basically it will be returned, it will not be traversed again, right? Now what we did was we called all its adjacents, row minus 1 and call, row plus 1 and call, row and call plus 1, and row and call minus 1, and then we simply return. So at last we finally return the answer. So like, I hope you all must have got the question, got the code also, got the approach also. Not a tough question, but one of the important questions. Like it has been asked in Amazon, and there are many similar kind of questions that could be easily made. So please do this question, and if you want the code, you can check the code in the. I will mention the GitHub. I will publish the code on GitHub. You can go and check that out, and do check out all the other problems on Get SDE Ready Question Bank. They are really very good. They have been filtered from all the online platforms, GFG, LeetCode, InterviewBit, or any other present over there. So you can check there. You can go through all the questions. All the videos are present on my channel. So yeah, that's it. I hope you liked the video. If you liked, you can hit the like button, and if you would want, you can share with the people. Thank you so much. Bye bye.